In this video, we will study comparison between permutation with identical items with and without replacement. So let us see the difference between permutation without replacement of n objects taken n at a time and permutation with replacement of n objects taken m at a time. Both of them are defined over a list of identical items A, B, C, and D, etc. and both generate ordered sequences, but in this case here, in the case of permutation without replacement of n taken n at a time, the size of the sequence is n. While in this case, permutation with replacement of n objects taken m at a time, the size of the sequence is unlimited. So now for the case of with replacement, we notice that any objects such as A can repeat from 1 to m times. So A could repeat from 1 to m times, or can disappear in the sequence, such as this sequence where there is no A in it. As for the case without replacement, so we have the original sequence, which is 1A, 2B, and 3Cs. So if we have one object such as A, then this object will appear only once. So we can have A again here. But if we have two identical objects B, they are going to repeat again only twice. As we can see here, we have again two B's. And if we have three identical objects, then they are going to be repeating 3 times again. As we see here, we have here 3 C's here and 3 C's in all generated sequences. Now let us compare between permutation of n objects taken n minus 1 at a time without replacement and permutation of n objects taken m at a time with replacement. So both defined over the list of identical items A, B, C, and D, and both generate ordered sequences, but the size of the generated sequences in this case here is going to be n minus 1 only. So the size will not be more, will not be less than n minus 1. While the size in this case, permutation with replacement, is going to be unlimited. So the size of the sequence here is unlimited. For the case without replacement, as we have seen before, so any object such as A in the original sequence, so we have the original sequence here with 1A, 2B, and 3Cs, and we can generate a sequence of m size. So in this case, A can repeat once or 3 times or m times, or can disappear from the generated sequence. As for the case without replacement, so we have the original sequence with size n, and this is the original sequence, and if we have one object A, then what happened to it? So we are going to generate a sequence with size n minus 1, so we may cancel A and we get a sequence without A, or we can cancel B and we are going to get a sequence with 1A. So we conclude if we have one object, then this object A repeats only once or disappears. Now if we have two identical objects such as B, so we have here two identical objects, they may appear 2 times, or we may cancel B here and B will appear only 1 time. So if we have two identical objects, then object B repeats only once or twice. And if we have 3 identical objects such as C, then we can cancel 1 C here and we may end up with 2 C's only, or we may not cancel the C, cancel another object, and we will get 3 C's. So in this case we say that if we have 3 identical objects C, then object C repeat only 2 or 3 times, and no more and no less. So let us now compare between permutation without replacement of n objects taken n minus 2 at a time, and permutation with replacement of n objects taken m at a time. As we have seen before, both are defined over a list, both generate ordered sequences, but the only difference is, in this case, the generated sequence size is n minus 2 only, while in this case here, permutation with replacement, generated sequence size is unlimited. As for the case with replacement, as we have seen before, so any object such as A may repeat once, 3 times, or may repeat m times, or may disappear from the sequence. As for the case without replacement, we are going to deal with this sequence, and it is for the case of 1A, 2B, 3Cs, and not less. So in this case, we need to generate a sequence which has the size n minus 2. So we may cancel A and B, and we get this sequence, or we may cancel B and C, and we generate this sequence, or we may cancel 2 C's, and we generate this sequence, or we may cancel 2 B's and generate this sequence. So what do we conclude from that? We conclude that if we have one object A, then object A repeats only once or disappears. So we can see here that A is repeating only once or disappearing from this sequence. But if we have two identical objects B, then objects B repeat only once or twice or disappear. So object B disappear from here, appear once here, and appear twice here in the sequence. And if we have 3 identical objects C, then objects C repeat only 1, 2, or 3 times. So for the case of 3 C's here, we can see in the generated sequence we may have 3 C's, 2 C's, or 1 C's, but C will not disappear for the case of generating n minus 2 sequence size.